Welcome back. In this video we want to take a look at the file structure of a Smali file because we digged directly into this file and we didn't talk about the structure itself. So this is something we want to do right now. And you will see this is not really complicated. We've got the structure most of the time, I guess 95% of this time. So let's have a look. In the first line we've got our .class public, and then we've got this capital L, which means we've got a class reference. And this one ends at the semicolon. So we've got our class reference to the player class. Okay, this was not really hard. In the next line, we've got this .super. And this means our player class is a subclass from this one over here. In this case, it's Java-lang object. As another example, if you take a look into our main activity, our .super class would be activity because our main activity is a subclass from this activity class. All right? So also not that hard. Next we've got our source, and this one is player.java, but I guess all said about this one. Alright, then we've got this hashtag at the beginning of the line, and this is some kind of separation. Okay, I guess I need to be a little bit more exact on this one. The hashtag simply just means a comment, and therefore the text is being ignored, the text behind this hashtag. This is not an instruction, this is simply just a text. This text has been created by the APK tool to support us in understanding the file structure. It is also being used to reference some values. For example, we have some hex values and directly behind them we have a decimal representation after a hashtag. This means the APK tool gives us some information about static field, instance fields, private and virtual methods, and also tries to help us in converting hex into decimal values, which is pretty nice. So to summarize this, a hashtag means a comment, and in this case it is some kind of separator, but only a visual one, not a technical one. Alrighty? So we've got several hashtags for different meanings over there. But between those we often have something called annotations. And these annotations are inner classes. If we're using inner classes within our player class, the Smali file needs to have this reference, and this is what this one is for. In our case, we do not have an inner class, for example, an enum or something like this. We will take a look into our SpacePang application to also get familiar with this one. Alright, next we've got this static fields, line 6. And the static fields starts with an hashtag. Underneath this one, we've got all static fields within this class. In this case, we only got one static field, which is lives. It's from type, correct, integer. Next, we've got this instance fields, also starting with an hashtag. Now we've got all our class variables. In this case, we've got power and shield. So you see, I've added some new instance variable over here. Next, we've got a new hashtag, and this one starts with direct methods. And this one is regarding to private methods, static methods, and also constructors. Regarding to static methods, this is a little bit special because the Dalvik bytecode has a certain reference for this one. So we do not find static methods in there. In this case, we can focus on constructors and private methods. Okay? And finally, we've got this virtual methods, which means we've got our public methods over there. And that's all. This is the whole Smali file structure. And if you get familiar with this, you can navigate even more easier around this file. For example, if you look for a certain instance field, you go up into this file, check out this hashtag sign and see, okay, here I've got all my instance fields. Pretty nice. Okay, I guess I need to be a little bit more exact on this one. The hashtag simply just means a comment. Therefore, the text is being ignored, the text behind this hashtag. This is not an instruction, this is simply just a text. This text has been created by the APK tool to support us in understanding the file structure. It is also being used to reference some values or types, like we see this over here, after a hashtag. This means the APK tool gives us some information about static field, instance fields, private and virtual methods, and also tries to help us in converting hex into decimal values, which is pretty nice. So to summarize this, a hashtag means a comment, and in this case it is some kind of separator, but only a visual one, not a technical one. Alrighty? Okay, perfect. So let's pull out our SpacePang application and navigate around a little bit in this file and also have a look into an annotations declaration. Let's go. Alright, here we are at our Ubuntu VM and let's check this file out. So we go into our directory apps, spacebank decompile. I mean, it doesn't really matter. Oh, it does matter. We use the APK tool approach because the JDX output is a little bit different and we want to look at the Smali code. So we need the decompiled version of the APK tool. Let's do this once again together that we have the same state. So APK tool, and then spacebank. Yes, then we go into this directory and I open the whole directory with Visual Studio Code. There we go. Okay, we also open it next to us with JDX GUI. Then we have the Java code, which is a little bit more easier for us to navigate and yeah, read this code. So spacebank decompile, JDX GUI, and this one. All right, so let's find this player class. We use this one over here. It needs to be decompiled and indexed. We also use this class field. I guess this class field is enough if we use only this one. Then we do not have all this distraction. We've got this in components player. All right, and let's put or open this in the Smali code. So we've got the E, components, player Smali. And I get rid of this one and we enable Java, even if it's not a Java code. All right, here we go. So let's go through this file once again. Okay, here's my graphic tablet. Let's dive into this. So we can see line 1, line 1, this one over here. We've got our class public, then we've got this class definition L, then this ends with the semicolon. So we also got this player class definition. But this time we have a different package name because we are within a different application. But this is our player class, this one over here. Okay, next we've got the super, and this one nice. We've got now a different one. This means this Artemis component is our base class and our player class is the subclass from this. And we can see this over here. We are extending this class. This is what this line means. Then we've got our source player Java. I mean, okay, we already talked about this one, not that hard. So next we've got this annotations. And this starts here and it also ends here. What do we have right here? We've got annotations Artemis, annotations pooled weaver. And this seems to be a class. Can we find this class over here? Yes, we are importing this class here at this line. So the Smali file needs to have a reference to this class, and this is what this annotation does. Next, we've got this one over here. We've got Dalvik annotations member class, player $state. We have already talked about this $sign, which means this one is our class, player. This is our separator, this $. Or let me draw this in a different color. And then we've got this inner class in our player class, which means state. So this is our inner class. Let's see where we find this class over here. Here. So we are having a reference from a different class in our player class. And yeah, this is what we've got over here. So if we take a look into this class, therefore let me toggle the screen real quick. There we go. Oh, okay, it's within this class right here. So here we define this state, which is an enum, and we have this enum directly in our class. So this can be an inner class, a complete new class, or an enum, for example. This also affects this enum. And this is why we have this one over here. This player $state. Okay. I'm gonna clean this up real quick, then we can move on. Yeah, this is all for this annotation files or this annotation description over here. We've got our two references. We've got this pooled weaver and we also got our state. Okay, next we've got static fields. We can see this with the starting hashtag over here. And we've got static fields, default lives, sprite name shield. And these are over here. So I also clean this up real quick. And then I need to drag this a little bit to us. Okay, public static lives, this one over here. And you can see they also start exactly the same way. Public static final default lives. Public static final, okay, we've got this int over here, default lives, but this int is within our type definition here. And we also got this value 5. We also got this over here and here. These are our 3 public static values, which are within this one over here. Then we've got a new hashtag, this one. And this signals us now those static fields are at the end. We've got new fields, in this case instance fields. We've got 3 instance fields. 1, 2, 3. Let's have a look. We've got them over here. This is an instant field, public int lives, and this is one score, and here we have our state. Exactly like we've got this over here. Cool. These instance fields also end up here, because here we've got now our direct method. Direct methods. Do you still remember what they are used for? Of course you can. Direct methods are used for private methods and constructors. In this case, let's see, we've got this constructor init returning void. We do not see this constructor right here, but it's of course available. The developer has not created a code for this, but if this object gets created, there needs to be a constructor, and therefore this is automatically added. We cannot find this over here, but it's still there. We can see this in the Smali code. So we already know more than the Java code. Super nice. Okay. We can also see this private and constructor methods ends up here. And here we've got our virtual methods. Virtual methods are, correct, public methods. And yeah, if I scroll down a little bit, we can see those virtual methods starts here and they end up here because we do not have a new hash sign or hashtag. This means we've got 2 public methods, isState and setState. This one and this one. Nice. And this is the whole file structure for this Smali file and also for all the other Smali files. Let's have a look at another example. So let me see what we've got. The sprite looks interesting because I can already see this $sign, which means we have an inner class or an enum over here. Let's have a look. Okay, now we are not opening the Java code. We are doing this only in the Smali code, and then we will compare this afterwards. So I can increase this a little bit. Let's go. All right, let's see what we've got. Line 1. We've got class public, our class reference, capital L. This one ends at the semicolon over here. The name is sprite. So we've got a class named sprite. Class sprite. And this class has a superclass. So we've got a subclass from component. We are extending this one. Extends component. Okay, then we've got this annotations, and we've already seen this in the Smali code over here. So at this point, let's see what we've got. We are importing this one over here once again. Okay, next we've got this member classes. So this one is an inner class. And this inner class is named layer. Can be an inner class or also an enum type. We can find this out if we take a look into the Smali code later on. For now, let's keep this as an inner class. So we simply say we've got a layer. And yeah, this variable name, let's call this also layer. Okay, then we've got a lot of instance fields over here. And we do not have a static field. So this class only has instance fields. And this one has A, B, G, this inner class, and string, and these are floats. Okay, some funny names, A, B, G, R, and so on. These are all those variables. And finally, if we scroll down a little bit, we've only got this direct method, which means we only have a constructor, nothing else in this class over here. So we can see direct method, and this one is the constructor. So this class, which is named sprite and is extending this component, sorry. Let me scroll up a little bit. This class now has all those this instance fields over here. So we've got an float A, we've gotten float b, and so on. And we do not have any methods. So no methods. But we have a constructor, this constructor over here. And this one is initializing all those values. This one, by the way, is super interesting. This looks really ridiculous at the beginning, and we will learn about this later on. So this is a floating point number, and your computer does not store floating point numbers in a way you might think if you haven't heard of floating point numbers before. So this one gets stored in some, really interesting way. We've got a bit which is representing the sign, if it's positive, negative. Then we've got some bits for the mantissa, and then we've got some bits for the exponent. And this is what this strange value is over here. But we do not really have to know this, because we can also take a look at this one, and then we can see, okay, this is the decimal representation of this floating point number. In this case, it's simply 1.0. Whoops. 1.0. Okay, that's just as a notice. We can also look this instruction up, const high 16 v0. And let's do this real quick. It's a little bit off topic, but yeah, let's do this. So I really hope you have bookmarked your Dalvik opcodes. And let me get rid of this one. So we are searching for const slash, const high 16. There we go. Puts the 16-bit constant into topmost bits of the register. Sounds complicated, but we are just taking the 16 bits of this value or of this constants and puts into our register. So if you would have a value which is represented by 20 bits, we do not care. We only take the top 16 bits out of this and puts it into this register. So we are losing some decimal values over there. Okay, this was a little bit off topic right now, but if you encounter this, do not be afraid. What I like to do in this way is I go into this and I see, okay, const high 16. So we are putting 16 bits into our v0 register, and we do not care what this one is. So we get rid of this, and there we go. Okay, v0 is 1.0 as a floating point. That's all. That easy. All right. Okay. Yeah, we have cleaned the screen a few times, but nevertheless, let's get back to the Java code, put them side by side and see if we, were correct on this one. I mean, you can go back in the video if I was wrong, but let's see. All right, now they are side by side. I'm also super interested about this because I did not prepare it in this way. I like to do these things, on the fly. Let's see. So we are in DE, fgerbig, spacepang, and then components, and then sprite.smali. Yes, I would say we were correct. We were correct. We've got only those values over here. We've got this constructor, which is missing. We've got no further methods, and we've also got no static fields. And we can also see our, the things we include. This one over here, and this is this class, our super class we are extending. Nice one. Okay, cool. By the way, if you are interested in this enum types, because let's have a look. There we cannot find this. And this is why we have these annotations. We can now check sprite layer, and within sprite layer we should see a reference to those values, background default effects. Let's have a look. There we go. Okay, let's make this a little bit bigger. Also enable Java once again. Here we go. So again, let's do this once again. I know it might be a little bit boring, but practicing this means learning those stuff. And even if you just watch, you will learn something new. Okay, we do not go that deep into this. We've got our sprite layer. So we've got our inner class, sprite $layer. And now we've got these annotations. We can see our enclosing class is sprite. This is now our main class in this case. And then we've got our inner class. This has some access flags and a name, which is layer. We do not care about those access flags right now. So we've got our name layer. So we've got sprite $layer. And then we can see, okay, this one is now from type inner. If you would have an inner class, this would be referenced here. Okay, and here we can see those labels. So we can see, for example, this one, actors, background, default, effects, overlay. This is how we can identify what we are dealing with. And this is why we have these annotations in our Smali file. Okay, once again, let's open this Java code side by side. We go into our layer, sprite layer. This one, yes. And here we can see them. Background, actor, default, effects, and so on. Okay, we do not dive into this deeper because this will be a little bit complicated if we take a look into this. So here you can see, okay, this looks interesting. I'm pretty sure if we go this step by step, line by line, we will be able to reverse engineer this part. But we are not doing this right now. We keep these things simple at the beginning and we will increase the tempo later on. All right, that's all for this topic right now. This topic was about the file structure, and we have seen what those lines mean, that we've got separations between those hashtags, and also what this annotation does. During the reverse engineering process of this file, we have seen we understand this file better and better. We get those external references, we get inner classes, and also have a nice separation between instance fields, static fields, private and public methods. Okay, in the next video we take a look at our player.smali file, the extended version, and we will do a reverse engineering process on this one together once again. And then we will have a quiz where you can practice this on your own. And afterwards we will patch our SpacePang application so that we will not be able to lose this game anymore. Alright, I see you in the next video.